Physical science time. Today we're talking about the method of writing formulas and naming compounds. I was going to do it in orange. Let's do it instead in magenta. Writing formulas. Yeah, you do have to take notes. Formulae and naming. Once again, compounds. Once again, in your book, this word is formulas. Some people abbreviate it formulas. I like to abbreviate formulae because that's from the Latin, and think about how fancy and smart and magical spell Latin makes you sound. I'm going to draw, first of all, a flow chart for writing formulas and naming compounds, okay? We're going to make a flow chart, and this should help you. I'm going to switch to blue because I'm noticing this is not really super visible, either to the little bunny rabbits in the room or to the people watching online, of which, of course, as you know, there will be hundreds of thousands, if not millions of viewers. No, but it might be someone in the future. I mean, no one knows. You might be watching this video as freshmen in the class of 2036 that I have as a really middle-aged person assigned you to watch because I was sick that day or something. You have to watch this, and I thought this was the best one I ever did. You never know. I mean, you could be watching this. Shout out to those of us from 2036. Anyway, so the first thing we're going to do is we're going to see whether this thing is ionically or covalently bonded. We don't do this for metallic bonding. Why not? Can you guess? Why would we not do this for metallic bonding? Go back to your notes. I'm going to answer it for you. Go back to your notes and look at the examples we had for metallic bonding. What was the example we had for a compound that is metallically bonded? Not really a compound. It was just iron. It was just iron. It was all iron mixed together. The thing about metallic bonding is it doesn't have to have a set ratio. For instance, even in an alloy, can you think of any alloys? Do you know what an alloy is? Fate does. Steel is an alloy, yeah. Yeah, alloy is a mixture of different metals, including steel. Carbon's not a metal, but it acts like a metal for that purpose of making steel. Another one that you're probably aware of is bronze. Another one is brass. Those things, for instance, brass is an alloy, a mixture of copper and zinc. Both metals. Look at that. Copper and zinc. Someone probably has something brass on their body right now. Everyone's wearing jammies or shorts. Who's wearing jean pants? Oh yes, sorry, the whole rancher group over there is definitely wearing jean pants. Your zipper is probably made of brass. It's kind of golden in color. If you compare it to real gold, you know it's not gold, but it looks like gold if you have nothing else to compare it to. That's brass. You know what copper looks at? What color was copper when we saw it in the lab? Yellow. No, it was copper colored. It's orangish. If it's scrubbed, it might be orangish pink. Zinc, we saw in the lab, was gray. If it's scrubbed, it's probably silvery white. But those two things together make a golden color, and that's an alloy. And those are combined in some ratio that is not definite. So we don't do this for naming and writing formulas and naming compounds for metallic bonding. We just don't. So we first have to decide, is it covalent or ionic? That's going to be step one of the flow chart. Covalent or ionic. Just like we did when we were learning about these things conceptually, how can I tell if a compound, two or more atoms bonded together, is covalent or ionic? What do I do? Look at their atoms, right? Look at what atoms make them up. If it is what, then what?
If it is helium.
That's way too specific. Gabe?
If it's two nonmetals,
Yeah.
it's covalent. If it's a nonmetal and a metal, it's ionic.
Okay, so first we see, is it covalent or ionic? I want to make sure that you have, well, actually, let's do it this way so I can make more sure. Let's put these in different bubbles. Covalent or ionic? If it's covalent, you'll find two or more nonmetals. If it's ionic, it'll be a metal and nonmetal. What do you use to find that out? You just have to have them all memorized? No, the periodic table. Where do you look to tell, God bless you, whether it's a metal or a nonmetal? The stair-step line. You look on which side it is of the stair-step line. For each of these now, we're going to have a list of steps. Would you like to start with covalent or ionic? It makes no difference to me.
Ionic.
Ionic. Good. Thanks for being decisive. For an ionic bond, I'm going to do this one actually. Let's do this one in black. Let's pretend this was in black. It doesn't matter for you, except for that maybe you think in colors like I do. To write the formula of an ionic compound, to write its formula, we have to have its name. So we're either going from name to formula or formula to name, depending on what the instructions tell us or what thing we already have. Do you know what a chemical formula is? Give me an example of a chemical formula. You should. Give me an example.
H2O2.
Yeah, H2O2 is a chemical formula. The thing that tells us their symbol and how many of them there are, that's the chemical formula. So let's get an example up here going. We have, let's do one from your book actually. Let's look at, I don't mean your book, I mean your little worksheet. Get out your worksheet. I'm on the back page, this thing that says Physical Science Naming Worksheet. This is part of your homework. Now available online, obviously. You can pause this to get the problems off of it. Number 1 here. I'm on number 1, which to me says, and if you're looking at the right page, it should say NABR. Do you see that? It says this. Is everyone with me on this number 1? Is anyone not with me, sorry, on this number 1? We're doing number 1, which reads this. So that's all we're given. We're given what is this thing? No, what is this thing? Compound. Yeah, this is what did we call it? It is a compound, but we named this little group here
Chemical. Molecule.
Formula. This is a chemical formula. This is a chemical formula. So from the chemical formula, we want to find there's the instructions. They say do what?
Ionic compound.
No, the instructions say name it. So we want to find the name. Here's how we do it for ionic compounds. We write the name of this one. Yeah? What's the name of this one? What's Na on this? Sodium. And then, step 2, this is bromine, but we always change the second one, the anion, to ide. We change its name, change its end of its name to ide. So instead of sodium bromine, it's now sodium bromide. As Fate already said, Fate did know it, sodium bromide is the correct answer. So let's go through the steps. 1, write name of cation. You remember talking about this? What's a cation? What charge does the happy little cat have?
Happy.
Happy is not a charge. What charge does the happy little cat, the cation, has a positive charge? So first we write the name of the cation. Here's a little hint. The cation is always going to come first. So if it says write the name of the cation first, and the cation is always going to come first, we just write the name of the thing that's first. Do you see? Write the name of the cation. 2, write the name of the, what do you think this other guy's called? If he has a negative charge, do you remember? Anion. Negative. But change the end to ide. And that's it. It does get more complicated, but that's it for these what we call binary ionic compounds. Binary meaning 2. Bi 2. Bisexual likes the sexes, both sexes, right? Bicycle has 2 wheels. A binary ionic compound has only 2 elements. How many elements does a binary ionic compound have?
2.
This one is binary. You don't have to write this for the questions. Binary ionic compound. Let's do one from the bottom then. Magnesium oxide. This says 7. Magnesium oxide. This is on number 7. So far so good, right? Do you have questions about number 1 before we move on? I should have asked that before we moved on. Questions about number 1, sodium bromide. Okay, let me ask you a question. If they were all like this, do you think you could do it right now?
Yes.
Yeah, it's just, you just write the name, and then you write the name of the second thing, change to ide, okay? Now here's where it gets a little bit more complicated, but you're still going to be fine. Magnesium oxide. Now we have what is this? Is this the chemical formula?
No, it's not.
No, this is the name. So now what should we do? Well, what do the instructions say? Provide the
Mn.
formula. So now we're writing formula.
Mn.
So nope. Mg is magnesium. Be really careful when you're looking these up. Magnesium, which is right here, is Mg.
What's the one that's Mn?
Manganese. You need to be careful with these. But now here's where you really need to be careful. Oxide came from what element? Probably oxygen. Okay, but here's where you need to be careful. you have to check the charges. I'm going to put this with exclamation marks. Check the charges. When you're starting out, if you think you're really great at this and you can prove to me that you're really great at this, you don't have to do this. But I would really, really like you, at least when you're starting out, to do it like this. Check the charges. Write the charge of this above it. So if magnesium has 2 valence electrons, how's it going to bond? What's it going to do when it bonds?
It's going to lose those.
It's going to lose those, how many? 2 valence electrons. Now what's its charge going to be? If it loses 2 electrons, it now has a positive 2 charge. So we write that above it. You can either write +2 or you can write 2 plus. It makes no difference at this stage. I want you to write that above it. Now let's go over to oxygen. Hi, oxygen. How many valence electrons does oxygen have? God bless you. 6. Once again, how do you know? That's the easiest way to know how many valence electrons it has. It's in group 6. So if it has 6 valence electrons and it wants 2 more, what's its charge going to be? -2. These have to, can you guess? These have to add up to something. What do these probably have to add up to? They have to add up to 0. Right now, do these add up to 0? Yeah, they do. So this is right. So MgO is the correct answer. We're going to do another example of one that won't be true for. 8. Okay, here, let's actually write the instructions down here again. 1, write symbol for cation. Again, write symbol for cation. Hey, just because I squatted doesn't mean you have to stop paying attention. Write symbol for cation. 2, what's the next thing we're going to do?
Charge.
That doesn't have to be next. Write symbol for anion. When I say symbol, you know I mean what it says on the periodic table, right? That's its chemical symbol. And then 3, this time has a third step. Change subscripts. Remember what subscript is? So charges add to, what do they have to add to? 0. Let's do, I ran out of room down here, so I'm going to move over here just for now. Actually, I'm going to move up here just for now. That's the sound of someone bulldozing their whiteboard. We're going to do it 8. Hopefully you all had that. I assume you did. Number 8 says aluminum. Stop talking, please. Once again, what is this? What have I been given?
Chloride. So it's
No. What have I been given? A name. I need to find it, as the instructions say. Formula. What's step 1? Write the symbol for the cation. So what should I write?
Al.
Al. Write the symbol for the anion. What should I write?
Cl.
Cl. Now, 3. Change the subscript so the charges add to 0. What's the charge of the aluminum? Check it out. And we're going to write this above it.
3.
3 plus, right? It's a metal, so it has a positive charge. 3 plus. Also, another way to find out, it's the cation, so it has to have a positive charge. What's the charge of chlorine? No, it has 7 valence electrons. What's its charge?
It would be...
Yeah, you're right. 1 minus.
Wait, how?
Uh-oh. Do these add to 0?
No.
So now what do we add? It says change the subscripts, but what, I need to ask you, do you know what mathematical operation the subscripts do? What is that going to do? If I put, for instance, if I put 3 here, how is that going to change this? Is it going to make it,
It's going to divide.
is it going to add 3 to it? Is it going to subtract 3 to it? Is it going to multiply it by 3 or divide it by 3?
Divide it by 3.
We have several different answers. It's going to multiply this number by 3. 3 chlorines, each with a -1 charge, has a 3 negative charge altogether. 3 freshmen, each wearing a gray shirt, means we now have 3 gray shirts, right? We multiply it. So we're multiplying the number of chlorines, which also multiplies the charge. 3 times -1 is 3 negative. Now do they add to 0? 3 plus and 3 minus, do those add to 0?
Erase the 1 then.
Yeah, well, it's still true. I'm just putting it above it. So they now add to 0, so this is right. So does it have to be just trial and error? No, there's a pretty easy mathematical way to solve this. You figure out the factor between these and multiply one of them by it. The hardest this ever gets is if we have something like 10 aluminum oxide. Well, once again, Al. What's oxygen? O. What's the charge on the aluminum? We should already know.
Plus 3.
3 plus or plus 3, either way is fine. What's the charge on the oxygen?
Minus 2.
Yep. 2 minus. Good job, Gabe. Now, look, what can we, is there anything we can multiply this negative 2 by to get 3? No. So that's not going to work. So we need to multiply them both to get to you remember, their lowest common denominator. You remember that? Or, yeah, lowest common factor. Which one is it? It doesn't really matter. What's the smallest thing that both of these,
6.
Well, yes, 6. So we need to multiply the aluminum by, to make it 6 plus, yep, we multiply that by 2, and the oxygen by 3. Al2O3 is correct. 2 times 3 is going to be 6 plus, 3 times 2 minus is going to be 6 minus, those add to 0. You may have to rewatch the video, you may have to do some more examples, but that's as hard as these ones get for the binary ionic compounds. So, writing the name is pretty dang easy. Even, look at 3. Look at 3 on the top. Do you see that one? Let's do 3 together real quick. Li2s. Do you see that?
Yeah.
Li2s. Remember, we only had 2 steps for writing their name. What is this one? Even with the numbers in it, it's still going to be lithium sulfide. We don't have to do the step where we check to make sure their charges line up when we're writing the name. So 3 is lithium sulfide.
It's warm.
Yeah, it is.
It's 80 degrees.
Your boy is sweating because I'm also shouting all the time, and I had a ton of coffee.
AC's on now 'cause it says 80 degrees.
Yeah, we're all doing our best. It does feel like we're in hell. Okay, there are 2 ways to complicate this. Yay, get more complicated. I'm going to have to move over here because I want to keep this up for people that are still using it. So we're going to... We called these binary ionic compounds. Now we're going to move on to what your book calls, I think it even calls them complicated. No, complex ions. Complex ions. When you're in chemistry, you have to have these memorized. You don't have to have them memorized this year. Complex ions, we're still in ionic. We're still doing ionic. They're now called... I'm on page 619. And in fact, you should be on page 619 too, because you will need this table. Yep, BT dub, this table will also be given to you on your test. You do not have to have this memorized, but I'm using for reference, YouTube viewers, I'm using this table.
Is it the second page?
I'm sorry, what did you say?
Is it the second page?
Oh, I'm sorry, the page of the worksheet. No, they're all still on this same page. We'll still do them on this same page. Complex ions. What does complex mean?
Hard.
No, it does not. It means that there's going to be more steps. There's going to be more to it. So instead of binary, where it was just 2 atoms, just 2 elements, how many do you think this is going to have?
3.
3 or more. So let's write that down first. 3 or more elements. Listen. Emma, are you listening? This is what part of your flow chart. 3 or more elements. This has to be on your flow chart because if you see 3 or more elements, you must use these rules. Are there any on here, this worksheet that we're still looking at, that have 3 or more elements? Look down the list. Are there any that have 3 or more? We're looking at 1 through 6. Do any of those have more than 2 elements? Well, does 1? How many elements are in number 1?
2.
2, sodium and bromine. In 2? 2, calcium and oxygen. In 3?
2.
2, lithium and sulfur. In 4?
2.
2, potassium and iodine. In 5?
2.
Try again.
3.
3, lithium, sulfur, and oxygen. Look at that. Number 5, actually I'll just write it up here. And number 5 has lithium, sulfur, and oxygen. Since it has more than 2, it's not binary, so we consider it complex. Something in here, let's write this down, because I always say this, I shout this loudly every year of my life for the last 9 years of my life, but I'm just going to write it down so you can write it down. Something in here must be what we call polyatomic ion. What's poly mean? Multiple. More than one is what it means, but polyatomic, multiple, what? Atoms. Multiple atoms. It's an ion that's made of multiple ion. An ion that's made of multiple atoms. Look at page 619. Do you see a table, for instance, anywhere that is labeled polyatomic ions? No. You don't? Let's try to look again. On page 619, do you see a table anywhere that is labeled polyatomic ions? Are you getting some kind of hint as to what resource you may absolutely need to do this worksheet? The book. You can also probably find these online, but polyatomic ions are listed on a table on page 619. There are many more than this. When you're in chemistry, I have you memorize 28 of them. You don't have to memorize any now, and there are not that many on this table. But let's check. Is anything on this table, page 619, for those 3 of you in the room that have a book, is there anything on the table that matches something we have in our given? I'm going to move our given down below what I just wrote so that we can do the work for it.
I don't see it.
Let's try again.
I see something. I don't know.
Li2SO4, sorry. Is there anything on the table in the top right of 619 that matches something that we have in our given, Li2SO4?
Sulfate.
Sulfate, exactly right. So we use this table and we find what matches. What's the name of the first thing? We still name them the same way. What's the name of the first thing? Lithium. Now, what's the name of the second thing? This whole blob here is one thing. And what is it? Hunter, you already said. Sulfate. 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 That's him. No. Sulfate, though. If it ends, the reverse of this when we get to writing the formula is going to be, if it ends in ate or ite, it has to be a polyatomic ion. So here was step 1. I'm going to erase over here. I've gotten a little bit chaotic with my writing, but you know that sometimes do happen in here. It really do be happen to Mr. Time. Now I'm going to write the steps that I would have tried to write underneath it, but I ran out of room over here. Step 1, we write name of cation. And we remember that it might be polyatomic. And 2, we write the name of the anion, remembering that it also might be polyatomic. Where do we go to find the polyatomic ions?
The book.
The book on page 619.
Top right.
Page 619.
Top right.
We could say, what was step 0? What did we have to do to tell whether we need this procedure or not?
Or ite.
Yeah, no, not for this one. If it has 3 or more elements. 3 or more elements. That tells us it's not binary, so something must be a polyatomic ion. Something must be a polyatomic ion. Let's do another one like that. There's only one more, and it's number 6, and now we've pretty much done all of them. Number 6 says, Cu... Oh, we can't do this one yet, because we don't know how. We don't know how to do that one yet. Let's go on to formulas. Formulas for complex ions. Complex ions, writing formulas. Let's do, hey, actually, you help me. Which one, as we go down the list, which one of these is going to have a complex ion? 14. Well, hey, you little scallywag. We can't do 14 because that's just this one. That's the same one again. It's just the other way. Let's find another one. Looking at this list, which one of these would probably contain a polyatomic ion, and how do you know?
Calcium carbonate.
Calcium carbonate. That's number 11. Calcium carbonate. How do you know, Gabe, that one probably has a polyatomic ion on it?
Because carbon ends in 8.
Yeah, because the 8 means that there's a polyatomic ion. Carbonate. 8 or ite, always polyatomic ion. Hey, listen.
What?
Thanks. Hey, listen. Does this say only? Are the only polyatomic ions? Always. Look at the list of polyatomic ions again. Do all of these end in ate or ite? No. Hydroxide ends in ide, and ammonium ends in ium. So they don't all end in ate or ite. But if they end in ate or ite, that's always going to have a polyatomic ion. Calcium, what's the symbol for calcium? Ca. Which polyatomic ion is carbonate? Do you see carbonate on your list?
It's CO3.
CO3, 2 minus. And that 2 minus tells us its charge so that we can do the thing we know we have to do. What's the charge of the calcium? Look at the periodic table. Positive what? No, look at the periodic table. Calcium is number 20. Positive 2. What? And this thing tells us what's the charge of the carbonate. It already told us in the chart. Negative 2. The chart says 2 minus. Those things are interchangeable. It can be either minus 2 or 2 minus. Do these match? Yeah, they do. They're already going to add up to 0, so this is the formula
For calcium carbonate?
for calcium carbonate. That was number 11. Hey, we have 2 more things to do. They're both, well, one's quite a bit more difficult than this. The other one's quite a bit easier. We'll end with the easy one, but we'll do both of them tomorrow. You can do several of these. I'm not going to tell you what not to do. If you feel unsure, all of the information you need to do this is in your book, okay? You will have time to work on this, probably now Monday. I'll probably change this to be due Tuesday. You'll have time to work on this both tomorrow and Monday. You're certainly welcome to work on it now. I would encourage you to only do, we got through 3/5 of it. I would encourage you to do the ones that we already worked on today now. Wait to do the ones you don't know until tomorrow. And if you want, you can wait until tomorrow to do it all together. You have questions at all? Does this feel okay to you?
No.
This is not the most mathematically complicated thing we do all year, but if you're good at math and not so good at this kind of puzzle, this might be the hardest thing for you all year. But do you feel okay with this right now?
Yeah.
Does anyone have questions? We'll have time to work on it. You just need some practice. Bye.